So this is me. This is me. So my name is Steve Poole. I work for IBM. I'm a lead engineer of a pretty large team now, and up until a couple of years ago, I was a Java developer. I did JVMs, lots of middleware JVMs and stuff like that. And as part of that, that was great. I was a developer. I knew all about that sort of stuff. And then I started to get involved in other stuff, and the cloud came along, and it became more and more important that I learned about DevOps and things like that. So I changed jobs, and now I'm leading a DevOps team. And right now what we're doing is trying to build DevOps tooling for as many IBM product teams as we can get to take them, because it's really important that we have good, solid foundations. And one of those is security, which is where this talk sort of came from. So it's a bit thin. So I'm not a security person. This is a practitioner's report. This is what I'm going to tell you I've learnt. And hopefully you're going to walk out of this being upset. If I've upset you when you finish this talk, then hopefully I've done my job, right? This talk started because of a thing called compliance, which is you must make your systems compliant, and that's what always happened. And I'm going, what does that mean? I don't understand what compliance means, and is it useful? So I need to figure out about that. As a DevOps practitioner, lead engineer, my team, we got bitten by security problems because we were naive and we needed to learn things. So this talk isn't about application design. If you want to know how to design secure applications, then this is the wrong place. This is about you and the bad guys and how that all mixes together, right? So mostly this is about you understanding you have to do things differently, right? And it's me telling you what I've learned so far. So there's lots of stuff to talk about. I'll see if I can get through all this. There's so many things here, and you're the first set of audience for this talk, so I apologise if it goes a bit awry. There is a small demo in it, and at some point we'll talk about the BB-8, if you can see the BB-8. Okay. So I'm going to talk about the problem, about security. I'm going to talk about who's at risk. We're going to talk about who the bad guys are. I'm going to talk about how they get in, what we're going to do to fix that, how you need to change, a whole set of stuff. And I'm basically going to skim across the top. Right. So let's start with the really horrible things. Let's start with the scale of the problem. Cybercrime realities. Cybercrime has changed. If I was doing this talk 2 years ago, it wouldn't look like this. It would look like hackers and people doing it for fun, and that's gone. What you've got to know is cybercrime is seriously real now, and it's organised, 80%, right? So you can imagine I come work for IBM. We put a lot of effort, because we sell to large corporates, to make sure that we've got the message right and we understand the issues. We have a whole bunch of people whose job is to go out and keep assessing this and figuring out what's going on. And they work with the US government, they work with everybody to understand what the situation is. Right? So here's the really scary thing. Cybercrime is the most profitable type of crime now. I'm sorry, you can't really see the red. So this year it's estimated to be about $445 billion. In 2013, the drug trade, the illicit drug trade, was considered to be $435 billion, so less than cybercrime. Which one do you think has the least likelihood of, the least risk? Cybercrime. Which one's growing the fastest? Cybercrime. It's basically going through the roof, and some of the worst estimates are looking at this being worth $2,100 billion in 2 or 3 years' time. It is the most lucrative business because the chances of being caught are so small, and the value that they get out of the exercise is fantastic. So here's just a little statistic. 2014, billion devices were hacked, billion data records were stolen. And you go, what does that mean? It means your data and your customers' data is being siphoned off. And as you'll see, this is now becoming an invisible activity. It's not something that you're going to be aware of, and that's the scary thing as well, right? And of course, there are loads and loads of millions of devices that are getting hacked. We've all got Android phones, we've got iPhones, and things happen. It's just really scary. I have to tell you, you have to wake up to this, right? This is something that you need to start learning. You're at a developer conference, so I will expect you all to be, actually somewhat culpable about what's happening here. But you are the guys who are going to fix that, and I'm going to talk about that. Right? But this is real, this is big, and it's going to get worse. So what data are they after? That's a good question. So it used to be credit cards. They'd come along and you'd use your credit card. And then something with some purchase appear on your credit card, and you go, oh, this is a pain, and you go off and you talk to your bank, and they'd go, yeah, have some money, it's all dealt with. We write that off as a cost of business. But that's what they're not looking for. Yeah, they still look for it, but that's not the big thing. Now the big thing is identity theft, learning about you, learning about your national insurance numbers, looking for the things that make you you, because they're worth so much more. Right? So they're not looking to hack your sites. They're going what's called quiet. I discovered cybersecurity, vulnerabilities, attacks, loud, quiet. Loud is you knew about it, quiet you didn't. It's going quiet because it's really worth money. Medical data, sensitive personal information, anything that gives them insight into you. Right? And of course they want access to your systems. They want all these things, and they're going about it fast, and they're going about it in an organised way. Oh, I should say, I'm going to put these little boxes up. I may talk about them, I may skip them, but basically I'm trying to put through some of the things that I've learnt, and if it's of interest to you, then come and talk to me afterwards. So, protect all your data. It's an obvious thing to do, but it's the first thing that we learnt was you treat your data as crown jewels, whatever it is, everything. Right? So they're after facts. They want to know about you, and they want to know about you and your customers. Anything they can steal from you, whether it's your email address, whether it's your date of birth, whether it's your Twitter handle, or there's all this public stuff, and then there's all the bits and pieces that you give away. They get these bits. How many people here are gamers? Yeah? How many people have you gone to you go to Steam or something, and you want to watch something, and it says put in your date of birth, because they want to check that you're over 18 or whatever, right? Lots of people, put your date of birth in, right? So now they've got your date of birth. If you don't realise that date of birth now with your email address now identifies you, you're a slightly easier person to find. Now I can go find more about you. Can I find out where you live? If I know how old you are, right? And I know what country you're in, I can go off to the various systems. I can go to Ancestry.com. I can probably find your date of birth. I can find your mother. If it's there, I've got your mother's maiden name. Got you there, right? And that's what they're doing. It's that methodical. They are looking for bits and pieces. They want to know what you think about your boss. If you're on Facebook and you comment about people and you do it in public, right? Then that information says you like or you don't like your boss. That's valuable, and I'll show you why, right? So, of course, other things like working up what sites you visited, because maybe they weren't the right sites. And now I know. Maybe I'll blackmail you. Maybe I can get you to give me access. Organised crime criminals, this is what they do. The more I can find about you, the more I can attack you, the more money I can make, right? And it's more than just technical. This isn't only about vulnerabilities and things like that. Right. How many people get spam like this? These are ones that came to me recently. Yeah, we know. Have your ATM card. We spot that one, don't we? Everybody gets those. Yeah. How about the FBI? Yeah, they're going, I think we'd like you to give some money, but these corrupt people, they didn't let you have it. And we laugh. Right? This is the one I got. This is like the weekend. I love this. Apparently, I've won a brand new 2016 model BMW Hydrogen 7 Series car, a check for $500,000 and an Apple laptop. It's just fantastic, isn't it? I need to retire. That'll be great. Right? So, no one falls for those. Well, here's a couple of semi-real ones. This is a classic. I said about the boss. Right? If you don't like your boss, you're frightened of your boss, and they know it, then it makes it easier to send you emails like this, or your colleagues. You get emails that go, need to do this quickly. And something like this came to an exec from their VP going, not my company, but this is, you can go read about these things, where they're basically going, get this done, send the money, here's all the details. And she did, right? It was only the fact that she mentioned it to a boss that they did something about it. Right? But, so she wasn't that frightened, but you get the idea, right? If they know more about you, they can target you. And you being developers, you being people working your finance, payroll, the whole thing, right? So if it's suspicious, you have to challenge it, right? That's just like number one. You have to do that. And you need to be telling people this is what you need to do. It's so important to be going, that's suspicious. And the reason you have to do this, and here's another one, here's an email. So this is a real thing. This is a picture of a real way bill. So again, somebody figures out that this person's really busy, and they craft it. This is I think this was a Japanese one, and they basically built a fake setup, and they got the wording right because they went out and employed the people who were in the business to create these things, and they sent it to the individuals, and the individuals went, oh, I'm really busy, yeah, it looks right, do it, because that was their job, right? This is a really nasty one. Part of some of this spam is, oh, by the way, go install this application, and we just do. This is the scary thing. People go, yeah, okay, I'll trust you, right? Our customers do it, our employees do it, we do it, right? As you'll see, we are one of the worst offenders for just trusting people, right? So if you install software and you don't check where it comes, of any type, whether it's an application, whether it's a Maven package, if you're not looking into where it's coming from and its provenance and checking it out and knowing what you're looking for, then you're going to get hacked, and you're going to get hacked quietly. So these attacks are moving from the general phishing things. There's this thing called spear phishing, which is very specific, and they're now going to you. They're going towards your company. They will organize around understanding what you do. They will keep looking for opportunities to find their ways in, right? And those things, those emails about the spam stuff, you go, they're really funny. We laugh at those. But think about this. Those emails are targeted at gullible people. Why would anybody who's trying to get somebody to give them money target people who are going to spot it? No. So the bar is set really low. If you fall for the email, great. You're unlikely to fall for anything else. But now they're going much more sophisticated. They're going after more intelligent people, unfortunately, people who are less gullible, but they are focusing on you, right? And they look for all sorts of places. They look for you, your information, and they bring it together and they target you. It's really scary. So they target people, middle-level execs. You don't go after the CEO, do you? You go for the people who report to him. You go for the ones who are frightened of their bosses. You go for the new guys. Right? The guy's just turned up. He doesn't know how the company works. That seems reasonable. He doesn't question it. Right? You go for busy people. We're all busy. Yeah, we've all done it. We all go there. We all get websites. Oh, yeah, that certificate. Oh, I'll just accept it. Right? Because it must be okay. And now we need to flip that. You need to be looking at it the other way around. So you need to be considering, why am I doing this? Why is it that the person at the other end of this is doing it suspiciously? Right? Disgruntled employees. Not much we can say about that. That's always going to be perennial. There are other bits and pieces we're going to go, well, we can't do much. If they find out that you don't like your company and you're willing to take some money to hack, not much we can do about it. Developers, you can do things to make it more secure, but it's always going to be a fact of life. Right? And developers. Most of us who are developers, well, we're targets too. We're targets because we're the weak, we're the vulnerable, we're the ignorant. Right? We really are. We just gloss over all this stuff. We assume somebody else is going to fix it, and that's what's coming out. And I can give you examples, but I'm saying it more and more again, that one of the biggest culprits for the situation we have is us, because we've let it get there. We've ignored security. It's a boring thing. We haven't really put the time and effort to understand, right? And we have all this information. We're the inside guys. We have root access. We have, we write the code, and we trust, and we just use other people's code. Yeah, I'll download that. There's all these talks, and they're going to say to you, go off and download this. And you're going to go, at what point are you going to go, how do I know that's secure? How do I know that's real? How do I know that the person giving that to me is the right sort of person? Right? I just follow the instructions. I go to Google. How do I do X? I Google. I take the scripts. I type them in. Does anybody ever check? Do you even think about it? Right? So let's just talk about who the bad guys are. Would you believe it's turning into, it's weird, it's turning into a bunch of people who are developers, who are organized using Agile. They do squads. They get together. They're very focused, as you can imagine, and they're there. They're very technical, and they know how this stuff works. These are the guys we're up against, right? And they share this stuff. This isn't guys in their room. There's a whole community of people, of criminals who are creating things and sharing them. There are guys who sell software to the criminals that do these things, right? Did you know that? Did you know how big the business is? It's massive, right? And the other thing is, we have a bunch of researchers, and I'm going to demo one of the tools in a second. We have a bunch of researchers who, for the right reasons, are trying to find all the holes in our systems so that we can patch them. And those tools get used by the criminals because they're there to hack your systems, right? Right. Oh, and 35. I don't know if that's good or bad, right? The other thing you should know about these guys is that they're real criminals, right? This isn't mostly hackers, who've gone to the dark side. What we're finding is that a lot of these people are already criminals. They just happen to have fallen. We have people learning about IT. Wouldn't that be good, right? So the first time these guys are learning about computers in prisons or whatever, and they're making use of those skills. They're better at this than we are because they have a more incentive to do it, right? Most of them get caught, don't get caught for the criminal activities, they get caught because of something else they're doing. Okay, and I think that's pretty ironic. Right, let's talk about how they get in. So there's the old-fashioned ways, social engineering, which is phishing and things like that. That's finding ways to make you open the door. That's standard. That continues. Vulnerabilities, right? So that's probably one of the biggest routes in. From a hacking point of view, if I can't get you to give me the keys, then I will be looking for the software vulnerabilities. And again, I'll talk about this in a second. And that's huge. And these guys go off and look and scan and use them because there are all these vulnerabilities out there that are being reported. We don't patch our systems fast enough or at all, so there are now have all these great holes. People have gone out. We have people who have discovered the holes in our system and have published them. And these guys are out stealing that information. Well, not stealing, they're using that information to get into your systems, right? Okay. And inside information, well, again, as I said, there's not much we can do about that, but that's what happens. We have people, your colleagues, right, who are doing it for money, and they'll share stuff. So vulnerabilities, let's talk about those. Bugs and design flaws, there's lots of them. It's inevitable. Now, I'm not going to say that this is not a talk about how you design your solid solutions, how you make them secure. There are other people doing that, much better at it than I am. I'm telling you the extra bits, the infrastructure piece. All software has vulnerabilities. It's inevitable, right? And we have researchers looking for them all the time. And so the bad guys, this is what they do. So here's 3 searches. Well, if you want to go for... Sorry, I'm being molested. Okay. So if you want to go to... that sounds better. Okay. So I would suggest if you want to learn... if you want to learn more about vulnerabilities, CVE is where they're all listed. And I did 3 searches this morning. So the first one I did was Java, which is up here, 1500. I did one about serialization, which is this one here, 32, I think. And then I did one about JavaScript, right? But there's nothing, I'm not trying to prove a point other than lots of these things exist. There are lots of vulnerabilities, right? And if you don't know them, if you don't know they exist, and you're not fixing them and you're not applying the patches, you're just waiting for your security guys to go, yeah, you just go do it, then you're missing a trick, right? You need to go look at these things. You need to have somebody in your team more inclined to go read about vulnerabilities and understand what they should be doing about them. You don't have to fix everything, but you need to be informed, right? Because these things are a combination. It's not necessarily, you may go, oh, I'm using WebSphere or Tomcat, and there are none for that. Well, no, they have componentry that they depend on. They've got vulnerabilities in. So it's about you knowing your systems and where the vulnerabilities are and making that connection. And this is not trivial, right? I'm not saying this is a simple thing, but this is the sort of stuff you've got to do. And the good news is so much of this is automatable now. There are software out there that will keep so much about scanning your stuff and telling you've got vulnerabilities. Whether it's Docker containers, VMs, operating systems, the technology is out there. You go find it, go buy it, but it's out there. And if you don't do this, then you're letting the bad guys in, right? So there were the old ones, and now there are new ones. New attack vectors, devices. Well, here we go. Everybody buys devices and plugs it into their net. There's just so many of them, right? So we'll talk about that. Ransomware you've probably heard about. That's where I get into your system and I encrypt your data, and then I charge you money to decrypt it. Okay, that's a bit blatant. That's not really the sort of thing that I was talking about. That's much more of the same lines as having your employees steal your data, right? It's a different thing. Yes, it's a problem, but what can you do about it? Well, some stuff. Blackmail, extortion, same thing. They're stealing your data. They blackmail you to give them the keys. Yeah, okay. And these things are growing, right? Because they're targeting you. They're identifying you, finding your weaknesses, and targeting you, right? It's incredibly scary. Right? They're putting malware into real products. So now start thinking about this. You get free stuff. You go to the Docker registry, and I see something. Great, go install it. How do you know what's in it? For Docker, for instance, if you've got a Docker file, if that Docker image hasn't got a Docker file, run, because you have no idea what's in it, right? Because what you should be able to do is take the Docker file and rebuild it. At least then you've got your own version. But don't trust them. You go to any site, you download stuff. How do you know what's in it, right? If it's helpful to you, it's free to you, it might actually be something that's good for them, right? Dangerous paid stuff like trainers. If you can't win, you want to cheat and you buy a trainer. That's the sort of thing that brings in viruses. Well, now it also brings in bogus certificate authorities, all sorts of stuff, steals data. And you won't admit to it because you shouldn't have been doing it, right? Source. They're trying to get changes into the source. So you get helpful pull requests. I fix this bug for you, right? How do you know that that's a good fix? Do you review it? Do you trust the person that's giving it to you? Do you check the person out? How much do you do in this sort of space? You probably don't. You just go, yeah, fine, that's really good. I've worked with this guy. We've exchanged emails. He's a nice guy, right? This guy's done some merges for me, if you can see that. This is another thing. You get somebody does some merges of fixes for you. You understand that when you do a git merge, or any sort of merge, you're taking two disparate sets of changes and you're creating a third one. There's no guarantee that that third thing has anything to do with the other two, and in fact can contain extra pieces. And that's been seen, right? Help for people, git merge, it's a bit blatant, but if nobody checks the fix, yeah, it's those two things put together, there we are, we're done, right? And once I get it into the source, it's there. I've just injected a vulnerability. The good news is we have so many vulnerabilities, this doesn't happen too much, right? Devices inside your network, wow. Smart printers, smart TVs, bring your own devices, and they all have default passwords. And if I can get into your network, which I can do quite easily, I can bring along stuff, I can plug in a Wi-Fi gateway, I can do that. Just so many ways into your network, right? And if you let me on premises, then that's easy, right? And they all have default passwords, right? And then you have computers where everybody knows the password, and it's just like forget it. There are just so many ways in, right? You cannot assume. You have to go from today and go, you have to operate as if every computer in your company is on the internet. You have to deal with it that way. You have to have secure firewalls. You have to be doing it that way. You cannot trust anybody, right? You have to have the strongest authentication and systems that you can, and you have to go home and do that, because this is where they get in, right? And I could talk about personal passwords. We all know about those. Oh, they're a faff. Why is it that I have to have an exclamation mark, or I have to have numbers and letters? Well, I suggest that you wander off to the Wikipedia page, and that will point you to a whole bunch of interesting tools that will explain to you how easy it is to hack your password and how much harder and longer it takes depending on whether you have uppercase, lowercase, whatever, right? There are whole rafts of calculated passwords. So I've taken your password hash. I can go to this. I can go buy files, and if you've taken a common one, it'll be in there. So I can find your password in like that, right? And this is for sale. In fact, it's not for sale. You can go download it. You can go do it yourself, right? So you know all the rules about passwords. You know, just they are so easy to hack if you do not do it properly, right? So Wi-Fi gateways. Well, getting onto my demo. Wi-Fi gateways, they're everybody here. How many people are connected to a Wi-Fi gateway right now? I am. Yeah. Okay. I'm now going to show you why maybe you want to think more about that next time. This is one that came up to me at the weekend. I was connected to a hotel Wi-Fi, and it came up and it said, Safari cannot verify the identity of the website, google.com. And again, what's going on? And then I read, login.required.open. Oh, okay, no problem at all. I know what's happened. I haven't authenticated to the hotel gateway, and I could accept this. And I went, no, don't want to do that because I don't know that's the case. So I backed off and went through it again to make sure that I really was connecting. But having connected one of these is great, but as you'll see, it's a bad thing to do anyway. But anyway, you get this sort of stuff, and we're all encouraged. We all do this. We see these, we accept them. Right, and it gets worse. You accept that, then you've let them slightly in. If you accept a certificate authority, which people will get occasionally, you've let them in forever. Right. Wi-Fi gateway. I was going to build one of these and bring it, but I thought I've just got too much to do, but I won't. So Raspberry Pi, couple of Wi-Fi dongles, a USB power supply, and a grey box. I'm going to build one of those, and I'm going to stick them on the wall. And it's going to say DevOps, and you're going to connect to it. Right? You wouldn't do that, would you? But you don't know. Right? So I'm going to show you the bad side of all this and how it all goes wrong in a minute. But what I'm trying to point out is the Wi-Fis that you connect to, how do you know that it's DevOps? How do you know it's anything? Right? And the answer is you don't. So before I do anything else, I have to do an advert break. So you may have seen the BB-8 on the bottom. Bear with me. Does that work? If you'd like to win a BB-8, if you'd like to win one of these, it's very simple. You have to answer one of these questions. You have to answer this question, and there's the answers. You pick one, and you do that by going down to Old Street Station, and you go into the store, and you put in your answer, and you win a chance of winning a lovely BB-8. Right? Lovely. It's not far away. One stop. Great. How about this? Because we're Platinum sponsors, there is a DevOps.online Wi-Fi gateway that you can use. And if you use that, we'll give you 10 times the chance of winning. Right? And it's secure. You can use it for everything. I mean, right? Why would you not do that? Yeah. Of course, you can't find the gateway. It doesn't exist. Right? It's good. Right? I did think about doing that, and I thought, what would happen if I did that? How many laws would I break? Would I ever get back to DevOps again? Right? Right? But the problem is, Wi-Fi gateways, they're everywhere, and we join them, and we trust them because we go, SSID is DevOps. or DevOps online, which has nothing to do with DevOps is mine, right? It's really bad because this is how something called man-in-the-middle attacks happen. This is the primary solution, primary way in, and I'm going to demo you one. So the demo is taking place here. So there are no physical devices other than the Mac. There are two machines, a client and a server. The server is running this man-in-the-middle attack, and you'll get to see what that is if you haven't seen one of those before. Running some great software called MITM Proxy, which is, you can go download this, obviously. It's gonna, the DevOps client cannot reach the outside world, has to go through this gateway VM, this little VirtualBox, through the Mac and out into the internet, okay? Right, so let's see if we can make this work. Okay, so this is the oops, bear with me. Okay, right, so that one is the target, and this one is the evil man in the middle thing, which I proved was already working. Oh, go away. Why won't you go away? That's better. Right, so basically, if I make an HTTP call here, says he, I can't see that. Oh, bear with me. Let's get rid of all this. So HTTP. There we go. So the man-in-the-middle system is over here, and this is off-the-shelf software, and you can see I can go through and I can see what's in the request. You can see that it's a window within a window within a window, but and I can get the response and I can do the details. That's an HTTP request, plain text. Oh, and MITM Proxy has some fabulous things for letting me change all that data. It's written in Python. I can write all sorts of stuff. Really great API. I can change this left, right, and center. Okay, so what happens if I do an HTTPS request? So let's try. So in theory, or actually it's working already. So let's go somewhere else. Let's go to amazon.co.uk. Is this going to work? I'm not using the DevOps Wi-Fi because it was flaky, but it's not looking good, is it? I will talk about what it does otherwise. Oops. That's not working very well. Okay. Right, so what I wanted to show you doesn't really, I just wanted to give you a flavour, this is this easy. What I wanted to show you was the fact that with the judicial approach, I can steal my HTTP Amazon credentials. Right. Oh, look, it did come through. Stuff is pilling up through this side. Right. So in this particular browser, I've already accepted a bogus certificate. Shouldn't have done that, but I got it there. Right. If I was to go to somewhere else, which is yeah, this is. Let's try this one. If I do I try this one, is it going to remind you? It's a bit slow, isn't it? Okay, well, this one is supposed to warn me. Maybe I've accepted the certificate there. But basically, it should come up and say, it's a bad site. Do you want to accept the certificate? Oh, no, I'm doing it wrong. Excuse me. What I should be showing you is this thing. This is the thing, this web page comes with MITM. This is where the bogus certificate is. Right. Certificate authorities are fantastic because they're the things that secure your site and prove that your key is correct and valid. But if I can get a bad one into your system, then you can't check. You have no idea whether the traffic is valid or not. So, yeah, sorry, it's not working as I expected. But with Firefox, if I try to do accept a CA, lots of stuff comes up. It asks me about what do you want to trust it with. Do you want to trust it for emails and things? Great. With Chrome, or at least at this version, what I got was, do you want to trust this? And I'm going, yeah, not really sure it is. And so 9 times out of 10, given that we're so used to accepting these things, I probably would. And once I do that, any traffic that I make with this man-in-the-middle system is the man-in-the-middle's property. So let me talk about how that works so that you can see. Let's go back to this. Okay. Right. So a few diagrams, the usual ones. That's the HTTP thing. Smiley face is me, my browser. Here's the website, internet. You can read the words. Give me data, return data. Easy. Man-in-the-middle attack with HTTP. Give me data. This system makes the request. So the MIT, the man-in-the-middle thing is making a request on my behalf, which I don't know. So it's not passing the request through, right? It's making it on my behalf. And so any data that goes backwards and forwards, it can do whatever it wants with, because it's plain text, right? And I might not know. Right? Now with HTTPS, it's more sophisticated, and this is really good. So what happens is there's a handshake between the browser and the website, right? And what you're doing is you're agreeing what level of SSL you're going to use, and then there's a random key that's generated by the browser. So basically, nobody can break this, right? Apart from going out and buying some quantum computing. Right now, this is as secure as it's going to get. There are vulnerabilities in some of the algorithms, but the process is really secure. Okay. So how do I get in? So, first way is, as we've all seen this, is that the man-in-the-middle thing makes the call, client-to-client handshake. The certificate comes back from the website to the man-in-the-middle, and it passes on a new certificate, its own certificate to you. So you're not talking to the server that you think you are, you're talking to an intermediate one, right? And then it's up to you whether you accept that, not the certificate, but whether you accept the key, and you go, yeah, we've all seen it. This is insecure website, and you go, yeah, fine, right? So once I've done that, for one connection to a server, it's all sorted. They can see my data, right? Because they're in the middle and you let them in, right? If I can get a bogus certificate authority onto your browser through any means possible, you won't even see this, right? And with that tool, I showed you, I'd like to have demoed you, but basically with that setup, I can go to Amazon and I can do an HTTPS put post with my details in, and the guy in the middle gets it because he's broken the security. Right? And if you have internal CAs, if you're a progressive company and actually sign stuff yourself, then if I can get hold of that and get it to the man in the middle, then again, the same sort of thing. Right? But I don't even have to go to this level of sophistication to steal stuff from you. There's a really simple way of getting your data. What happens here is if the first connection to a server is HTTP, unencrypted, that first connection is vulnerable because I'm going to give you back unencrypted data. So if you make an HTTP request to a website and it gives you back a web page that's got a post on it, and the post is HTTPS, log in here, submit details, etc. Well, I can strip that out and make it HTTP. So the browser doesn't know, puts the details in, you put the details in, you press the submit, goes to the guy in the middle, steals your data because you sent it to you, and then tells you the website's gone down or gone away. And, damn, refresh. Right? And at that point, the man-in-the-middle system's out of the way. It's not going to interfere anymore because it's got it what it wants. It's got your password. After that, you've made a connection, right? And the only sign that you had that may have happened was that unexpected, when I did a refresh, or when I did a post, it said the server's gone down. And we've all had that, right? Right. So there's a diagram of how that works. But basically, it's trivial, right? And this is one of those jokey things. You can go read about this. Lots of people, researchers go, it's a bit loud, but it's easy, right? So the simple answer is getting your data from a Wi-Fi gateway is trivial. There are so many ways of doing it. The simple answer is VPNs, right? You have to have a VPN, right? And you want all your traffic to go through that VPN to a gateway that you trust, because if you don't, you're making yourself fully available for hacking. And of course, it's not just you, it's anybody who works for your company. If this isn't in your psyche about how to prevent this happening, right? And of course, the other thing is HTTP. If you're connecting to a website that where the default is HTTP rather than HTTPS, tell them you don't want to use that anymore, because it's just no longer the good thing to do. Right? All the big sites don't do that, right? If they do it, they'll redirect you. There won't be any chance of you getting an HTTP, an SSL strip, as they say, where they pull out the data, right? So you can't guarantee, if you don't do this, if you don't have a secure connection all the time, you have no idea what's going to happen. And it's not just browsers. We all use code that goes off the internet and pulls things down. If it uses HTTP, then all bets are off. If it uses HTTPS, it's slightly better, but we'll see, right? And my biggest takeaway here is we have to know how these systems work and how the authentication processes work. If you don't know how they work, then you don't know whether they're working properly, right? Right. And we have tools that we turn off. It's just amazing. People go, yeah, I just said it so it'll validate any certificate because it's easier, right? Right? Or it's self-signed, and it's just so much easier to do that than deal with the big problem, right? And then you have people going, well, I thought it was right, but we never test it. People go, yeah, okay, it works. How do you know you're making a secure connection? Have you tested it? Have you proven it? Right? And then we go, I trust you. You're the security guys, you fix it for me, right? And then you have, occasionally you get well, I wrote a script, but it doesn't do what I wrote it to do, and I think maybe somebody's changed it, but I have no idea, right? So basically, if you're going to be using these tools, you've got to use it right. You can't be sloppy over these things. You've got to take an interest, right? It's just mad. If you don't do this, then if you're not testing, they say 33% of people don't test mobile apps for security. Right? We're just letting them in. You guys are letting them in. If you don't have proper testing for security, proving it works and proving it doesn't work, and understanding how it should work, then again, they're in. Right? So when I speak about this, it's not just Wi-Fi gateways. You may remember, it wasn't that long ago, there was this thing about Node getting broken. And Node got broken because one of the guys who wrote one of the components, I can't remember the exact details, pulled it. And it broke everybody. So he put it back. I think somebody else put it back. My point is that guy, or any of these guys, could put stuff into that source code. We are so trusting, and we don't have the mechanisms to ensure that these things are correct. And where the mechanisms exist, we don't know how to use them properly. Right? So don't download this stuff without understanding what you're doing. I mean, I just can't say it any more plainly than that. Whatever it is, whether it's RPMs, Debians, Maven packages, Node, NPM, if you're not clear about the provenance of the people providing it, right, and how it's getting to you, and that security, then you're running the risk of bad things happening. Right? What we suggest generally is start building your own packages, your own repositories, and be careful about what goes into it. Right? And it's like Docker images. Right? Don't take them blindly. Right? Build your own. Prove it works. Keep track of them. Right? And by the way, all those default passwords, why do you let that go on? Right? If you're going to... my Raspberry Pi has a default password. If I was sharing Raspberry Pi binaries for people to use my organization, first thing we'd do, we'd change the password. Right? I'd love to find out where I could change the password in multiple ways, but you get the point. You can't tolerate these things, so you have to be calling them out. Right? Right. So, the recap, cybercrime is the biggest thing. It's just getting bigger and bigger, and we have a responsibility to make sure that it doesn't get any worse and that we fix the problems. We have to become knowledgeable. Right? We're not very good at this. Right? It's almost like built in. Right? Right? The funny thing is, this is CEO of Applied Visions, is cyber security guy, and he's saying, well, basically what it is developers aren't paying attention. We're very good at getting people to fix them afterwards, but getting it into our psyche and understanding about how we write good code and how things work from a security point of view, we're oblivious, right? We generally have to be better at it, right? So more security, more conscious. You have to be more intimate about how the bad guys get in. You have to be educated, right? Stop trusting people just because they're a developer. Start building a better trust relationship. Figure out how this stuff actually works. If you do not understand how HTTPS or any of these security and encryption works, then you're one level down. You have to learn those things, right? You have to have security in there. If you've got security architects, bring them into the design process. If you haven't, go off and get some, right? So, finally, a couple more bits of advice. This is just stuff. I have so many things, little bits that we hit. What can I pull out here? Hack your own systems. Yeah, that's really good. Learn how this thing goes wrong. The best way of learning how vulnerable you are, go off and try and find it, right? Don't do admin over a random Wi-Fi. If you haven't got a VPN, then you shouldn't do it, and ideally you shouldn't do it anyway, right? And don't add developer backdoors. We're so good at doing that. Yeah, I've got a special password or a special combination, I'm in. Yeah, it gets found. And ask yourself a few more questions, right? Do you need root, right? Would you have one key for every lock on your house and your car and everything? No, okay? Would you share? Why would you share this? Have the root password. Yeah, great. Have power of attorney over everything I've got as well, because that's what I'm doing. I'm giving you the keys, And why would you not change the default passwords? Why do you let that go on, right? Would you have a front door with a lock that everybody's got the key to? No, right? And why would you remain ignorant of how your system works, how your security works? Would you remain ignorant of the fact that you've got locks on your doors and you've got locks on your windows? No, right? That is what we have to start putting into the development process, right? There is no magic wand here. It's in our hands. I can't say much more than that, right? It is our problem. We're at the front of this. It's getting bigger, right? And if we don't catch up, it's going to get very, very bad. And actually, amazingly, I'm finished. Thank you very much. If there are any questions, I have 3 minutes. So does that include question times? I have 3 minutes. Any questions? Have I scared you? You're not running for the doors? Yeah. Okay. Well, thank you very much for listening.